Yeah. So
Yes,
is
sir.
my screen visible?
Yes, sir. Good evening,
Yes,
sir.
Yeah. Fine. So let's begin the session. So in the previous session, we were discussing this Python basics. So we had discussed various data types and the data structures also. We have discussed list, tuples, and sets. So one more thing left, which is dictionaries, right? So which is like a hash kind of data structures that we're going to discuss in this session. After that, we'll also discuss the conditional statements, like if, else if, else, all these things. We'll also discuss this looping statements, like for loop we'll discuss. Okay, but there are other possibilities also. While loop is also there, so you can, if you want, you can do it. So while loop syntax is more or less same as in case of C, C++. And we'll also see how to define our own functions. Okay, and then we'll also explore some of the important libraries that are important in the context of this machine learning and data science. Okay, so we'll start with NumPy, Pandas, and Matplotlib. To whatever extent that we can cover in today's session, we'll cover that and we'll continue it in the tomorrow's session. So this is what is the agenda for today. Okay, so let us start with the dictionaries. So dictionaries are like hash-like data structure. So what is the advantage of hash? Advantage of hash is that you can access any element with order of one time if you know the key value of it, right? So I'm starting with the dictionaries. So first thing is how to define a dictionary, right? So there are multiple ways that you can do it. One possibility is if you want to create an empty dictionary, just give the curly brackets, opening curly bracket and ending curly bracket, closing curly bracket. Then it is automatically taken as a dictionary. So if you don't specify anything, if you specify some element separated by commas, it will be taken as a set. Okay. So now, as I have mentioned, in the dictionary, we have the key value pairs. So we have a key and the corresponding value, right? So in order to insert an element into the dictionary, you have to access that using the key. Like for example, here the key value, I'm defining this key value corresponding value as a 1. Okay. And there is another value, another key value, let's say 2. And the key value, the value corresponding to this, I'm defining it as a 2 and so forth. Now, if you see this D1 and a type of it, okay, now you see that it's like a dictionary, key value pairs separated by column, key value pairs separated by column. So here ONU1, text 1 is the key value, numerical 1 is the corresponding value, and TWO2, which is the text 2, is a key value, and the numerical 2 is the corresponding value. So this is one possibility that you can define a dictionary. There is another way that you can do it using the dict keyword, right? So there is some keyword called dict, dict, okay? So which creates the dictionary, So in the similar way that you can create the dictionary, so you can directly give the dictionary as an input for this dict keyword. So I'm just giving here d2 equivalent to dict of this input, whatever the input, this key value pair input I'm giving as input for this dictionary. So you can see the same here as well. It's the same, right? So both of them are same, right? You can define them at a time, or you can first declare an empty list and assign a key value pairs. Okay. So now how to update this elements of the dictionary. So suppose instead of 2, I just want to put 2. Okay. So how do I define that? So let me just print D1 for our reference. So I just want to update the value of this 2, TWO2, right? So I just have to access it using the key value TWO2. Instead of 2, you want to set it to 2, right? So you can print it again. You see that the value is updated, right? There is another way of doing this. there is another way of doing. Suppose now 2 I want to convert this into back to 2, right? So there is something called d1 dot update. Okay, so in which whatever the value that you want to update, mention the corresponding key and values, right? So you want to update this entry. So updated entry you can mention here TWO2. You want to update it to 2, right? Now you can again print it so that it is updated back to this 2, right? So like this. Yeah, so like this you can update the values, right? Similarly, if you want to remove the elements from this, you have to mention the corresponding key values. Okay, so d1 dot pop, I just want to pop off this element, right? So d1 dot pop, mention this element name, right? Key value TWO2. Then you can print this d1 again. Now you see that we have only one element, the other element has been removed. So this is how you can insert the elements or update the elements or remove the elements from the dictionary, right? Now I'll show you how to create a dictionary from two different lists. So taking one of the list as a key values, the other list as the values, actual values, right? So one of the list we are taking as a keys, the other list we are taking as a values. So key value pair, we are taking each one element as a one key from one of the list and one element from the values as the value, right? So let me define the two list. So I'm defining the keys list here. So the keys list is ONE1, TWO2, THRE3, right? So let's say these are the keys. And let us also define the corresponding values. The values list is 1, 2, 3. So now we want to make a dictionary by taking each one value from each one of the list and form a key value pair. So 1, 1, 2, 2, 3, 3, like that, right? So how to do this? So in order to get the pairs, we have to zip them together, right? So if you want to get each element pairs, right, the corresponding element pairs from the individual list, we have to zip them together. So zip them together, you're zipping them together, keys and the values. Okay. So once you zip them, you can even visualize that it is like an object, but you can convert that into a list. Okay. So list of zip of these values. Okay. So you see that. So this is like a two value pairs, right? Key value pairs, 1, 1, 2, 2, and 3, 3. So just to show you, I have given this. I've converted that to list, but actually we have to make it as a dictionary. So dictionary of zip of this key value pairs, right? So once you convert this into dictionary, it returns a dictionary. You can store it in some name, like let's take D3 or D2, whatever. Okay, you can print the dictionary now, D2, or sorry, D3. Now you see that it's created a dictionary, right, from the two different lists. Okay, so this is how you can create a dictionary from the two different lists. There is another way of doing this. Another way of doing this is like you can have like a for loop, right, and repeat it over the all the key values. I mean all the what do you call this? All the elements of the individual dictionary. Okay, so let me show you that. Okay, so there is another way of doing this. So let us take the same keys and values. Okay, are you following, right? You're following, right?
Yes, yes, sir.
Yeah. Okay, fine. So let us take for in the length of keys. Okay, that means we are taking the length of this keys list. Okay, which is 3 basically, right? So what we want this one. Let us take another dictionary D4 here. So let me define D4 as a empty dictionary. Empty dictionary. Now I'm taking D4. So the keys are I'm taking from the keys list. So keys of I, D4 of keys of I is equivalent to vals of I. Okay, so this means for each indexing value, I am referring to the keys list and I am accessing one element and putting that as a key value. And I'm accessing the values and taking that as a value. So this is like defining the key value pairs of the dictionary. So when you take I in the range of length of keys is how much? 3. And this I will be repeated in the range of 0 to 2, right? 0, 1, 2, right? So I value will be 0, 1, and 2. So keys of 0 means what? only 1, isn't it? Keys of 0 is only 1 and values of 0 is 1, right? So keys of 1 equivalent to 1 and keys of 2 equivalent to 2, keys of 3 equivalent to 3. That's what it is doing in this loop. Okay, now you can see that you can print this D4 dictionary and it will be the same as that. Okay. Oh God, is int object is not iteratable. Give me a second. Please give me a second. Okay, yeah. So what is that? Int object is not iteratable, but this is not int case. Length of keys. Okay, I think I have to take the range of this. You know what the range does? This is the integer number, right? It just returns the 5. When you take the range of 5, it will iterate it over 0, 1, 2, 3, like that, till the length of this. Okay. Okay.
ಚೇಂಬರ್
Let me mute.
ನೀವು ಟಿಪ್ಪರ್ ಎಲ್ಲ ಬಂದ್ರೆ ಎಲ್ಲಿ ಉಳಿತಾವು ಗಾಡಿ ಎಲ್ಲ ಒಳಗಡೆ ಹೋಗಿ.
Yeah. So now you see that it is creating a dictionary of this, right? One, the key value and the corresponding value is 1 and so forth. Okay. So like this also you can create a dictionary. So you can even create a nested dictionary. Nested dictionary, like let's say that this is the dictionary. Nested dictionary is the dictionary of dictionaries, right? So dictionary inside another dictionary, right? So let me take another dictionary, D5. D5 is an empty dictionary I'm defining. So one of the value I'm inserting here, D5 of numbers. Numbers is the key value. And the corresponding value I am taking as another dictionary, D4, right? So now you can print this D5 and see this. This is the nested dictionary, dictionary of the dictionaries. So this is the outer dictionary in which the key value is numbers and the corresponding value is another dictionary. So in order to access this, suppose if I take D5 of numbers, what do you think it will print? D5 of number. What do you think it will print?
First dictionary.
So in a dictionary it will
Complete
print,
dictionary.
right? The complete dictionary it will print. So suppose if I want to access a particular element in this, I have to open another bracket and pass the key value of this dictionary. Let's say TWO2. Now you see that it is accessing the element in the inner dictionary. So like this, you can create a dictionary of the dictionaries. And I'll also would like to demonstrate this, how to copy the dictionary, right? So if you copy the dictionary values directly, like the way we were copying the list, right? Suppose if I say that some D6 equivalent to D4, right? So, and now I try to make the changes to D6. Let's say I'm just making TWO2 to 0. Okay. So whatever the changes that I am making in D4 will also be reflected in D6. Okay. You see that both the lists are changed. TWO2 is changed to 0, right? So now if you don't want this, what we have to do? You have to make this D4 dot copy, not D4 equal to D6 equal to D4. D6 equivalent to D4 dot copy. So now whatever the changes that you make to this D6 will not reflect in the other one. Okay, so let me change this back to 2 now. You see that it will not be reflecting in D4. It means D4 will be the remain same. It means it will be 0 only. Okay, now, okay. What happened? Yeah, so you see that D6 is modified back to 2, but D4 is remaining this with 0, right? So if you just want to copy the elements or the values only, you just have to call it by copy, D4 dot copy. Don't directly assign it. Okay, so this is another thing that I would like to, I wanted to demonstrate. One more thing is that you have an facility to access the only key values of the dictionary or only values of the dictionary or the items of the dictionary, right? So let me show you how to do that. So let me take one of the dictionary for our reference. Let us take D2. What is D2 or D3? You can take D3. Yeah, this is D3, right? Suppose if I just want only the key values of D3. So D3 dot keys you can call. It will access only the key values. You see that all these are key values only, right? 1, 2, 3, text in 1, text 2, text 3, right? Similarly, if you only want the values, you can call D3 dot values. D3 dot values will access only the values. Okay, you see that only values 1, 2, 3, numerical 1, numerical 2, and numerical 3. Right. So if you want the information about the dictionary, you can access D2 dot items. Okay. D2 dot items, then you will get this key value pairs. ONU1, TWO2, 2, 3, 3. Right. Key value pairs. All right. So that is about the dictionary, various operations that you can do with the dictionary. A lot of other things also, one you can explore them once you get the confidence. Okay, so I'm just giving you the introduction of everything so that it is easy for you to explore things. Okay, so just for the sake of completeness, let us also cover the various operators that the Python supports. Okay, so I'm giving the operators. I hope you're with me, following, right?
Yes, sir.
So addition.
Yes, sir.
Yeah, thank you. Subtraction, multiplication, division, floor division, anything else? Power, 5 power 2, right? I think we forgot one more thing. Then, modulus. So can you guess what A will print, what B will print? C, D, E, F.
7, 3,
7, 3, 10.
1.
Then 10, after 10, how much it is? This one, 3.
Remainder, no?
2.5, right? 5 divided by 2. It's 2.5, isn't it? 5 double division by 2. This is the floor division. So what is the quotient value that you get when your 5 is divided by 2? 2, right?
2.
Floor value, 2, right? And this 5 modulus 2 is giving you the remainder value. So what is the remainder?
1.
1.
Right? And 5 to the power 2. This means the 5 to the
25.
power 25, right? So you see that. 7, 3, 10, 2.5, 2. 2 is that division, right? Quotient value. 25 and 1. 1 is the remainder value. Okay. So these are the various operators that the Python supports. And Python also supports the binary operations. Okay, I'll just give you a few examples. But there are a lot of other binary operators also that Python supports. Okay. Okay, so let us take A equal to 5. What is the binary representation of this? 101. Okay, I'm just taking 3 bits, but in general, how many ever the bits that the Python that the system supports. So 2, it is 0, 1, 0. Okay. So when you take this A or B, what will be the resultant? A or B. Pipe symbol we use for or representation of R. A or B. What will you get when you take A or B on 101 and 010?
1 1 1
111, right? All ones. All ones means 7.
7.
Right. And when you take AND, A and B, then
sir 0 0 0
0 0 0. And when you take XOR, this is also 7, right? Because they're different, right?
yes sir
Yeah, 7 0 7 so far. Okay, so when you take the right shift or left shift of this A some right shift 1. Okay, 1 bit I am shifting it right. So what happens? You will get 0 here, 1 here, and 0 here, right? So total, how many 0 1 0 means it will become 2, right? All right. Similarly, when you take the left shift, you may get 10 10 1 0 1 0 you will get. Okay. So 2 and 10. Like this, various binary operations also you can perform. Okay. So the next we'll see the conditional statements, how to write conditions like if else conditions, if else conditions, like that. Switch condition is same as in case of C or other languages. You can go through that. Okay. Even this if else also almost the same except for the few changes. Okay. So what is that we will write? We'll write whether a given number is an even number or not, even number or odd number, right? So let us take the input from the user. So I'm just taking the input from the user. Input, I'm just asking the user to enter something, enter some number, and I'm just making it as an integer. Okay. And then once you get this number, what is the logic for even number? X modulus 2 is equal to 0, then it is an even number, right? So one more thing that you need to remember in a Python is that if indentation level, right? So Python, for Python, indentation is automatic in the sense that if you don't give the correct indentation, it will throw you an error, right? So it means whatever that you want to write inside the if loop, it should be at the next indentation level like this. It should start from here, right? And you have to give colon here. When you give colon here and press enter, it will automatically at the cursor will be at the will be automatically at the next indentation level. And whatever that you want to write at this indentation level, you can write. Suppose if you're starting another if or another condition or another looping statement inside this, whatever that you want to be inside that if should be at the next indentation level, right? Suppose if I'm writing another if here, so you should be at the next indentation level, right? Whatever that you are writing inside this if should be at the another indentation level, like that. Okay. So for now, I'm just writing only the one if here, not the nested if. So here I just want to print that it is an even number. Okay. Otherwise, it is an odd number. Okay. So yeah. So if you want to, if you don't want to write anything more, you can go to the previous indentation level and write the else statement here. Else print odd number. Okay. Fine. So perfect. So enter some number 4. So you see that it is printing as even number. Enter another number, let's say 5. So you see that it is printing as an odd number. Like that. You write the if else statements. Next one is else if also we have in case of C or other programming languages that you know, right? So how to write the else if? Now this time we'll take another condition else if. To write the else if, the keyword is ELIF. ELIF. You need to specify the condition inside the brackets. Right. Some of the versions supports without brackets also. You can directly write the condition. Some of the Python versions does support that. Okay. So here I'm just taking the x modulus 3. If it is equal to 0, I'm just writing here. Okay. I'm just writing here that print it is divisible by 3. Right. not even number. Okay, so divisible by 3. I just try to divisible by 3.
Sir, it is necessary to give space between F and the bracket.
Not necessary. Just for I mean my readability, I'm giving this. Okay, you can give this also, but there is no harm in giving. Okay. Okay, so let me write here. This is odd number but not divisible by 3. Okay, so let me enter some number here. Oh God. Why is that? Give me a second. Without entering, I have just repressed it. It is waiting for the input indefinite. I'm just refreshing. God. Give me a second. Let me restart it. Yeah. So 5 odd number but not divisible by 3. 9 divisible by 3. Some 4 even. So like this, you can write the if, else if, and else statements. Then we will look at the looping statements. For loop, we will see. Okay, so how to write a for loop? So we have already seen, right, one for loop, right? So for I in the range of 5. So the range of 5 basically returns values 0 to n minus 1. If you give range of n, it will return the values 0 to n minus 1, right? So it means 5 means 0 to 4. So you can even see that. So let me just print I value here. So this is returning 0 I in the range of 0, 1, 2, 3, 4, right? So like this it returns. Suppose if you want to start it from 1, we have to give 1 comma 5, right? So 1 to n minus 1, whatever that you specify here, minus 1, right? So like this you can print, you can even write the nested loops also. So like for example, I can write for I in the range of 1 to 5, and for j in the range of 1 to 3, okay, and print I comma j. Okay, see that 1 1 1 2 2 1 2 2 3 1 3 2 4 1 4 2, right? Because we were just given a range of 1 comma 3. It means 1 and 2 values only in the second loop, right? So like this you can write the nested loops as well. Okay, so you can also do this whole thing in a single statement. Like for example, I just want to print this ij if I less than j, right? So let me write like this. First, I will write using this without, multiple statements like this. If I less than j, then only you print this. Okay, fine. So now you see that this is what it is printing, right? 1 and 2, only one condition, right? So now if you want to write the whole thing in a single statement, okay, so you can do the same thing here. So what you want to do, you just want to print, okay, you just want to print this, whatever it returns, you just store it, the result here, you just want to print this. So print I comma j for I in the range of 1 to 5, remove this for j in the range of 1 comma 3, and whenever this condition satisfied, right? If this happens, if I less than say, right, close this. That's all, you're done, right? You can write the whole thing in a single line as well. You see that it is just returning the same 1 comma 2, right? You can see that as well, right? So like this, you can write the whole thing in a single statement as well. Sometimes when you want to write, you can write that. Okay. So then let us move to functions, how to define our own functions or the methods. Okay. So let us take, we'll see how to define the functions with the default arguments, or functions with a variable number of arguments, and we'll also see how to define the anonymous functions, right? So all these things we will see. So we'll start with some normal function. Let's say I just want to sum up two numbers. So the input for this, so any function should start with this keyword definition of the function, def. This here sum is the function name that I'm giving here. But sum, you see that it is in the green color. It means already some built-in function is there with this sum, right? So to avoid the conflict with that, right? Of course, it will not have any conflict, but for our convenience, right? To have a different name from the existing function sum. So I'm giving sum underscore. This is the general notation that we follow usually, that if you have some variable name or a function name that you want to give, and that is already there in the Python, that we give underscore for that. So a comma b, I'm just taking the two values, and it returns sum of the a comma b, a plus b, sum of a plus b, right? So that's all done. Okay, so if you want to give like c equal to a plus b return c, all that fine. So whatever that you want to define inside this function should be at the next indentation level. All right, so I just simplified it and gave this. So I'm just calling this function now, sum underscore, okay, sum 2 comma 3, let us pass. Okay, so 2 3 comma 4, whatever, right? You see that it is returning 7. So like this we can define the function. We can even define the function with a variable number of arguments also. So let us take another function, sum underscore, let's say 1. Okay, so this time I'm just taking some variable number of arguments. Okay, so I'm just taking some variable s, which is equivalent to 0, and I just have to repeat this over all the elements of this arguments, right? So for each element in these arguments, so I'm just repeating it over, sum equal to sum plus element, whatever the element that you get there, and just return this as, that's all done. Okay, so let me just execute this. So I've executed this definition. Now I just have to call this function to utilize this. So I'm just passing 1 comma 2, it is returning 3. So I'm just passing 1 comma 2 comma 3. Then 6, it is returning 1 comma 2 3 comma 3 comma 4. Any number of arguments you can pass, variable number of arguments, 15 and so forth. Right. So you can even define the function with some default arguments as well. Default arguments means if you don't pass anything at that location, at that place, then it will take the default value. So let us take c equal to 3 here. So the default value for c equal to 3. It means if you don't pass anything in the place of c, then it will automatically take that value as a 3. So if you pass something, it will take that value, whatever value that you pass there. So like for example here, I'm just calling some, Okay, so let me define it this way, sum underscore 2. Okay, so I'm just calling this sum underscore 2 with 1 comma 2. So it will take the third argument as a 3, right? Because that's the default argument. So what it will return? 1 plus 2 plus 3, default argument 3. So total is 6. It should return 6. Okay, you see that. Suppose instead of this, I just pass it some other value, let's say 10. Okay, so now it will take whatever the value that you pass here. It means it will return 13 now, right? So if you don't pass anything, the default value will be taken. If you pass something, whatever the value that you will that you are passing, that corresponding value will be taken automatically. Okay, so this is the function with a variable number of arguments. So you can define even the anonymous functions with no name also you can define using the lambda keyword, right? So here I'm just defining some keyword, I mean some function only. So z, right? So some variable name you can give, right? So you're taking this lambda, which means you're defining this anonymous function. Inputs for this are x and y, and the return value is x plus y. Okay, this is how we define. So I just executed it. Now if you call z of 1 comma 2, you see that it returns 3, right? Z of 1 comma 4, it returns 5, and so forth. So like this you can define the anonymous functions. There is another thing, there is a map function that maps the individual elements of this list that you pass to the function. Like for example, there is, let's say, list. Okay, so let me take L1 equal to some 1, 2, 3, 4, right? So now I just want to convert this individual element of this list to the strings. These are the integer numbers now. I just want to convert individual elements of this list to the string, right? That means I just want to map the individual elements of this to the string function. So I'm taking the string function in the map function, and the input for this is L1, right? So it will iterate it over all the functions, all the elements of this L1. So let me call the resulting one as some, what is the string one? Okay, so S1. So I'm just taking S1 and print S1. I see that. Okay, so this is like an object, but you can convert that into a list again. You see that individual elements are now converted to strings, right? So fine. So like this, you can map anything, right? Like for example, you can even map this individual elements of this list to some anonymous function as well. Like for example, you just want to sum up the individual elements of the to list. So let us take the to list. Let's say L1 equal to this. Okay, and let's take another value. So L1 equal to this. L1 equal to this. Okay, and L2 equivalent to some, let's say 4, 3, 2, 1 this time. Okay, I just want to sum up these two vectors, okay, or these two lists, right? Element wise sum. So you can now have this map function. Okay, so some map function you can define, define an anonymous function lambda. This takes x and y as the input and returns x plus y. And the inputs, this is the function that you're defining. Inputs for this you're passing as L1 and L2. Okay, so now you can have print the list of this. You can take this as a resultant or RES. Okay, so you can print this list of RES. Okay, you see that it will be 5, 5, 5, 5. It's element wise sum. You can see that, right? So like this, you can use the map function to map the inputs or a list of elements to a certain function, right? Fine. So far, are you with me? Following, right?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yeah. So
Yes, sir.
we have covered data types, data structures. Then we have covered operators. Then we have covered conditional statements.
Sir, one question. Can you please explain the lambda, that is anonymous function once again?
Yeah, yeah. So the lambda is anonymous function. It means without even giving any name also, you can define some anonymous function. So here you see that the lambda keyword used to define the anonymous function. So inputs are before this column and the output is after this column, right? So it is taking this inputs, this anonymous function taking the inputs x comma y and returning this x plus y. All right, so like this you can define any anonymous function with inputs and the output specified before and
So
after the
the
column.
input to x1 and x2 is passed out from this list L1 and L2, right?
L1 and L2 are the list, right? So, but we are not directly passing L1 and L2 as input for this. We are having the map function. So what map function does? It is mapping the individual elements of this list to this function. That means it is taking one element each from the L1 and L2 and mapping it to this function. It means first time it is giving 1 and 4, right? So 1 plus 4, how much? It is returning 5, right? The next time it will return, it will give 2 plus 2 and 3. So it will return 2 plus 3. Next time it will give 3 and 2. Then it will return 5. Next time it will give 4 and 1. Then it will return 5. So like this. Got it, madam?
Okay, now it's clear.
Yes, sir. So without a map, if you are using lambda, then x plus y comma whatever the like true value or otherwise
X
the
plus y you giving now. Then it will
yes.
just concatenate L1 plus L2 means concatenation of L1 plus L2. It will return that.
Okay, sir.
I mean, if that is a feasible addition, then it will not throw any error. Otherwise, it will throw an error. So L1 plus L2 is feasible only, right? It just concatenate, right?
Yes, yes.
Yeah. Fine. The next one we'll discuss is the NumPy library. NumPy is for basically vectorized numerical computations. Okay. So here NumPy is like, you can think of it like an array, replacement of an array. Okay. So you may immediately get a doubt that, sir, we have already having list, which is a substitute for the arrays, right? Why do we need another thing same as that? Am I right? Have you got this doubt or not?
Multi-dimensional.
Multi-dimension also there in list also, right?
Yes.
So NumPy is basically used to work with the arrays. Okay, it means it serves the purpose of the arrays. But we already have one data structure list which serves the purpose of the arrays. Okay, but problem with the list is that they are slow in process. Slow in process because the elements of the list are not stored at the continuous locations at the memory, in the memory. Okay, so NumPy aims to provide an array object that is up to 50 times faster than the traditional Python list. Okay, so it means if you compare the NumPy arrays with the list, they are 50 times faster than this list. NumPy arrays are 50 times faster than the list. Okay, so because these NumPy arrays are stored at the continuous locations in the memory, unlike in case of list. So the processes can access and manipulate them very efficiently because of the concept of the locality of reference. Okay, so you can even observe this. You can write one program with a list, another program, the same program with a NumPy arrays, and observe the time. You will observe that this list takes a lot of time. Okay, so one of my students have done this. So he has told, I've asked him to do implement something, and he has implemented everything using the list. And I've asked him to take the result as the average of the 50 runs. He said, sir, with one run itself, I'm taking this 10 hours of time. If you want me to run 50 runs, then it will be 50 times 10, 500 hours, right? I was quite surprised because when I was doing the same in C, I was just taking, it was just taking few seconds, okay, or few minutes, okay. Even if it is a bigger data set, it was taking some few minutes. Then I've asked him that what data structure that you've used. List, he said that I've asked him to replace every list with an NumPy array. Then surprisingly, it is Even with the 50 runs also, you can do it in minutes, not in hours. Okay, so it is that much faster as compared to the list, 50 times faster than the traditional Python list. Okay, so to use this NumPy library, we have to install it first. If you are doing it in the local Jupyter notebook, okay, or any local editor, if you are doing it, you have to install that. If you are doing it in Google Colab, you need not install anything. You can directly use any library. You need not install. You can directly use it. But if you are doing it in a local mission, then you have to install those libraries. If it is already installed, you can directly use. If it is not installed, you have to use it. You have to install that. So to install this, I'll tell you how to install this. You might have installed this Anaconda, right? Right. So go to the search bar, type Anaconda. Okay. So Anaconda prompt will come here. So you click on Anaconda prompt. So once you click on the Anaconda prompt, one console like this will be open. There you type pip space install space your package name, right? The keyword for your package. So here I want to install NumPy, let's say. It is already installed in my system, but just to show you, I am typing this. So it may say that requirement satisfied, something like that. Okay, so pip space install space NumPy. So this will say that, yeah, you see that requirement already satisfied. So like this you can install, right? NumPy most probably might have installed in most of the systems. So pip space install space NumPy. So if you similarly, if you want to install pandas, pip space install space pandas. If you want to install matplotlib, pip space install space matplotlib. If you want to install torch package, pip space install space torch, like that, right? So go to the Anaconda prompt and install it. Then to use it, we have to import that here. So to import, we have a keyword called import. So import space NumPy space NumPy. This will import the NumPy library. If you want to rename it with some short name, you can rename it as NP. As NP means you're just renaming it as NP. So it means instead of NumPy, you can use NP and access every object or every function that the NumPy library supports through this object NP. Okay, so you can access any function or the Today I'm hearing so many languages. I don't know what language is this. Earlier I had heard
Bengali.
What is that language?
Bengali.
Bengali. Okay. So import NumPy as NP. Okay. So now to create a NumPy array, you have to call np.array, np.array or numpy.array. Okay. So here you can create array of multiple dimensions. Sir, please mute yourself. Partha sir, please mute yourself. Partha sir. Okay, so you can create array of multiple dimensions. You can create array of 0 dimension, 1 dimension, 2 dimension, 3 dimension, and so forth, right? So 0 dimension means it's a scalar type, right? So I'm just creating here np.array of some scalar, which means the 0 dimension. There is no dimension for it, right? So np.array of 1, I'm just passing some scalar 1 or some element. You can pass any element 1, 2, or 5, 7, 8, whatever that you want to mention. So now I can even create an array of a single dimension, np.array. You pass the list of elements here this time. So 1, 2, 3, 4, 5, like that. Okay, so this will create a one-dimensional array. So you can even create two-dimensional array also. Okay, so that let us take some simple names on. See, two-dimensional array also. So this time you just have to pass the two-dimensional list as an input for this, right? So np.array of So let's take some 1, 2, 3. Okay, and another list 4, 5, 6. Okay, so now you can even create a 3-dimensional array like the same fashion. You can do that. Okay, so
Incoming voice call from NNITW.
So I'm just taking B equivalent to another one, np dot array of 3 dimensions this time. 1, 2, 3, 4. This is 1 2-dimensional array. So let us give another 2-dimensional array of the same type. Okay, this time I'm just giving 5, 6, 7, 8. Okay, so now you can look at the dimensions of them. You can print them as well as the dimensions of them. So to get the number of dimensions, you take the variable dot n-dim. N-dim means n dimensions, number of dimensions. Okay. Similarly, you can also have b dot dimension, c dot dimension. Okay. Number of dimensions in C, number of dimensions in D, and so forth. Right. So now you see that 0, 1, 2, 3. So the first array A is of 0 dimension, second array B is of 1 dimension, the third array C is of 2 dimension, the fourth array D is of 3 dimension, like that. Okay, so you can even print these values as well, like you can print A, print B, you can see that, right? So this is the first only one element, this 1-dimensional array 1, 2, 3, 4, 5, and then 2-dimensional array 1, 2, 3, 4, 5, 6, right? So like this we can create a multiple dimensional arrays, and copying is same as in case of the list also. Like what is that we use? We don't want to copy by reference, you just want to copy the values. What is the function that we use? What is the function that we use for that purpose? Hello, do you remember?
Yes,
Copy
sir.
function. Copy function.
Copy function, right? So a equivalent to a dot copy. Sorry, a copy equivalent to a dot copy, right? So let me take b equivalent to b, or sorry, b copy. So b copy equivalent to b dot copy. Okay, so it means whatever the changes that you make to b copy will not be reflected in the b if you do this. There is something called view function, b dot view. It means it's just to create a view of that. It means whatever the changes that you make to b view will be reflected in the original function as well. Okay, so b copy of 1 equivalent to 0. Okay, so let me just print b and b copy both. Okay, so you see that. So it is not reflecting, right? So because you have called by b dot copy, so what are the changes that you're making to b copy are not reflected in b, right? So like this you can copy the elements of a numpy array. All right, so there is another thing that is important and we use it most of the times, is that to get the shape of numpy array, right? So let's me print see what is the shape of it, what is the size of it. It is of size 2 by 3, isn't it? 2 rows and 3 columns, am I right? So if you want to access the shape of it, you can get c dot shape. Okay, so c dot shape you can call. So this will give return you the shape of it, 2 by 3, as you see this. Okay, so now if you want to reshape it to 3 by 2, instead of 2 by 3, you want to reshape it to 3 by 2. So 3 by 2 is compatible with 2 by 3, right? So in both the cases, the number of elements is equivalent to 6. So the reshape, and in the reshape function, you need to mention the size of the reshape. So you want to reshape it to 3, 2, right? So okay, so it will return the array after reshape, right? It will not modify the original array. Please note that. So it will not make any changes to C, but it will just return the reshaped array, right? So I'm just printing that. You see that this is the reshaped array, which is of size 3 by 2, 3 by 2. All right. So suppose if I don't mention anything at one of the locations. So suppose I just want to make it 3 by 2. So, but I'm not sure that how many of the other dimension. So if you're not sure about the other dimension, you want to create 3 rows, but you're not sure about the number of columns, how many columns you would get. So if you're not sure about it, you can give -1. It will automatically take it as a 2. So if the one dimension is 3, what is the other dimension compatible with the number of elements in the C? What is the other dimension compatible with? How many elements are there total in C? 6 elements, right? So if one of the dimension is 3, what should be the other dimension? 2, right?
Of
So
course,
that is the, yeah, so it will automatically take this as a 2. So suppose if I give 6 here, so you can see that it is same as that. Suppose if I give 6 here, what is the other dimension compatible with this?
1.
1.
1. So it will take it as a 1, and you see that it is taking that as a 6 by 1, right? Suppose if I give it 1 here, then 6, it will take it as a 6. You see that, right? 1 by 6. So like this, you can even give -1. Suppose if I give -1 here and 6 here, what it will take in place of 1 -1? It will take 1, right? 1 by 6, right? So like this, you can use the -1 for this purpose. Okay. So that is about the shape and reshape. Now, how to iterate it over the elements of this NumPy array. Okay. So how to write the looping statements on the NumPy arrays. Okay. So let us take B for this purpose. So this is the B 1, 2, 3, 4, 5. I just want to iterate it over all the elements of this B, right? So for each element in B, for each element present in B, just print that element. You see that it is iterating it over all the elements of this B. All right. Similarly, if you want to access this two-dimensional array or two-dimensional NumPy array, let us take C that. C is the two-dimensional NumPy array, right? So two-dimensional NumPy array, let me print C. So for each 1D array present in the, for each 1D array present in the C, okay, so repeating it over C, and you have to write another statement, right? So for each element present in this 1D array. Okay, so first you are iterating it over all the 1D arrays. The next loop is to iterate it over individual elements of the 1D array. So print this element. Okay, so you see that. So it is iterating it over each element, each 1D array of C, which means suppose if I print this 1D array here, what do you think it will print? In the first iteration, it will print 1, 2, 3, and in the second iteration, it will print 4, 5, 6, right? You can see that 1, 2, 3, it is printing. Then inside loop, this is going. This is iterating it over all the elements of this 1, 2, 3, and printing 1, 2, 3. Then that loop is completed. Then the outer loop, the second iteration of the outer loop. In that, it is printing the second one-dimensional array, which is 4, 5, 6. Iterating it over the second one-dimensional array, which is 4, 5, and 6. So like this, it is printing. So similarly, you can iterate it over 3-dimensional array, 4-dimensional array, any number of dimensions. Okay. There is another way of doing this. You need not write the multiple loops. There is some function called ND iterator. Okay, so that you can see here. Let me print C again here. So this is C, right? So you need not write the multiple loops. Okay, so you can instead do this. So I just repeating it over for each element in np dot nd iterator, n-dimensional iterator of this C. Okay, so print the element. It will do the same job as that. Print element, not C, sorry. 1, 2, 3, 4, 5, 6, right? This is the ND iterator. Even you can get the index numbers of these elements as well. If you call this ND enumerate instead of this ND iterator. instead of ND iterator, I'm calling the ND enumerate here, which will iterate over the elements and also pass the index numbers. Okay. So I'm just giving the index, printing the index as well here. So you can see that element 1 is present at the index 0, 0. Element 2 is present at index 0, 1. Element 3 is present at index 0, 2 and so forth. So it will return that as well. Okay. So like this, you can iterate it over all the elements. Okay. Please give me a second. Yes. So this is how you can iterate it over all the elements of the NumPy array. So the next thing that we're gonna see is that how to concatenate the multiple elements, and we'll also see how to perform the matrix related operations or the search operations in the NumPy arrays. Okay. So I'll show you how to concatenate the NumPy arrays. And before that, let me also show you how to access this NumPy arrays. Okay. So how to access this NumPy arrays we will see first. Then we will move to this move to how to perform various matrix operations. Okay. So let me show you how to access this NumPy arrays. So let us take some two-dimensional array first of all for this purpose. So this is the two-dimensional array. Suppose if I just give print C of 0, what do you think it will print? C of 0 means what? What do you think it will print?
First element.
First element of
One.
the first element of the
First
outer
array.
array. First
First
array, right?
one,
One,
So
two,
one.
first
three.
element, yeah, 1, 2, 3, it will print, right? So the first one-dimensional array, it will print. So if I give C of 1 here, then it will print the
Oh,
second
Second row.
one-dimensional array, right? Second row it will print, right? Suppose if I give 1, 1 here, then it will access the first row in that first column, right? So it means it will access 5. 1, 1 is a 5, right? Am I right? So it is 5. Suppose if I give 1, 3 here, 1, 2 here, then 1, 2,
6.
6. It
six.
will return 6. Okay. So you can even do that looping also using this. I mean, the range of values. Suppose if you want to access, you can even do that. Like for example, I just want to access 1, 2, 4, 5. I just want to access 1, 2, 4, 5. So 1, 2, 4, 5 means, should I repeat over all the rows or not? I should repeat over all the rows, right? Okay, so
Yes, sir.
print C, row numbers are starting from 0 and ending at 2, right? Ending at 2, 0 and 1. Ending at 2 means, 1 means 1 plus 1, which is 2, right? We always give this ending index plus 1, right? So this is 2. So you can even give colon directly because you're repeating over all the columns. Colon, it means these rows are repeated over all the rows. Then what are the columns that you want to access? You want to start at 0th column and you want to access the first column. It means first column means 1 plus 2 you have to give here. Am I right? So 0 is to 2 you're giving here. Now you see that you've got 1, 2, 4, 5. So now can you tell me how to access 2, 3, 5, 6? 2, 3, 5, 6. If I want to access
Sir,
2, 3,
1
5,
comma
6.
1 colon 3.
So here instead of 0 colon 2, I have to write 1 colon 3, right? So 1 colon 3. So suppose I just want to access 2, 3. Then I just want to access 2, 3. Then anyone?
The first portion you
Sir,
have to
we will give
modify. That is
0.
first row.
This one. You instead of
Huh.
column, what should I give
Huh.
here? Only one,
Two,
only zero, right? Only
huh.
zero, only the first row I have to give that, right? Right. So 2 comma 3, you see that it is printing. Okay, so now a question to you. Suppose, let me print again here. Suppose I just want to access 1346. 1346. Then
1, 3, 4, 6.
so first of all, should I repeat it over all the rows or not? 1346 means.
Yes.
Colon.
So the first one is colon, right? Right? There is no change in that, right? Colon will repeat it over all the rows, all the one-dimensional arrays. So now if I want to access, what should I want to access? 1346.
0th column and the second.
Second column, right? It means I'm
Yeah.
starting at 0, ending at 2. 2 plus 1 is 3, right? And what is the step size that I want to take here?
It's
1 or
2.
1,
or
2.
2?
2.
2, right? So we want to skip one of the thing, right? So 2 I'm taking. So you see that 1346. So like this, the NumPy arrays supports this kind of slicing as well, right? That's another advantage of this. You can access a subarray of this, okay, any element in the array. That is another advantage with the NumPy arrays. I mean, all these operations are very easy in case of NumPy arrays.
Can
Similarly,
you explain this once again?
yeah, sure, right. So here I wanted to access 1346, right? So 1346 means I am accessing all the rows. That is why I've given column here. Is that clear, sir? Till that
Yes,
part?
sir. Yes, sir.
Okay. So among the rows, I want to start from 0th row and at the second row, second column. 0th column, it means this, the first index, this first column.
Yes, sir.
And end at the second column, right? Second
sir.
column is 0, 1, 2.
Yes,
The
sir.
third column is actually index number 2. So because we want to end at 2, here we have given 2 plus 1, 3 and index. And here this is the step size. When you give the step size, it will, after accessing this 0th index, it will take a step of 2, 0 plus 2. If you give 1 here, or if you don't give anything also, by default the step size is 1. So 0 plus 1, 1, 1 plus 1, 2, like that it will go. But when you give the step size as 2 here, after accessing the 0th index, it will directly go to the 0 plus 2, which means the second index. It means it is skipping the elements that are present at the first index, which means it is skipping 2 and 5 and directly accessing 3 and 6. Got it, sir?
Okay, sir.
Yeah. So this third one indicates the step size. Okay. All right. So now you have to tell me d-dimensional arrays with respect to the three-dimensional arrays. Sorry, three-dimensional arrays. So if I give d of 1, what it will access?
Sir, 1, 2, 3, 4.
1, 2, 3, 4 or 5, 6, 7, 8? Index number, please
So
see
this
that.
is 5, 6, 7, 8 starting from.
5, 6, 7, 8, right? 5, 6, 7, 8. So if I give d of 1, 1, then it will just give 7 and 8. Am I right?
Yes, sir.
Okay. Suppose if I want to access 1, 3, 5, 7. How do you access that? Do I have to repeat it over all the two-dimensional arrays for that? All the two-dimensional arrays. This is the first column. Do I have to repeat it over all the one-dimensional arrays inside the two-dimensional array? I have to do that, right? It's a column. Then I have to access the first element in every one-dimensional array, right? So I give 0 here. Fine. So this is 1, 3, 5, 7. Fine. So like this you can access. So now suppose if I want to access 2, 4, 6, 8, then what should I give here?
In place of 0, 1.
I should give 1 here, right?
1.
Suppose if I want to access 1, 2 and 5, 6, then 1, 2 and 5, 6. So do I have to repeat it over all the two-dimensional arrays? I have to repeat it over all the two-dimensional arrays. So inside all the two-dimensional arrays, do I have to repeat it over all the one-dimensional arrays for 1, 2, 5, 6? No, right? 1, 2 is a one-dimensional array and 5, 6 is another one-dimensional array. But these two we are not repeating, right? It means the 0th element of the two-dimensional array we are referring to. And again, every element present in this one-dimensional array we are accessing. So now you see that this is 1 to 5, 6, right? 1 to 5, 6. That's what we wanted, right? Got it? I hope you got it. So can you now tell me if I want to access 3, 4, 7, 8, then how do you do that?
All the elements.
3, 4, 7, 8. So what should I write here?
Instead of 0, it will be 1.
It will be 1. Great. 3, 4, 7, 8. All right. So like this, you can access this any number of dimensions using this logic. Okay. Fine. So this I forgot actually. So that's why I came back to this. Okay. So let's move on. Now, how to concatenate the multiple NumPy arrays together, right? Fine. So let us take some two one-dimensional arrays. So let me take A equivalent to np dot array of some 1, 2, 3. Okay. So similarly, let me take some B equivalent to np dot array of 4, 5, 6. So if I want to concatenate them together, there are multiple ways that you can concatenate them together. One possibility is just appending them. Okay, so now I then just take another array C equivalent to np dot concatenate. Concatenate is the function to concatenate the two arrays, right? So you have to pass them like a tuple A comma B as a pair, right? So now you see that, let me just print this, see. So this is how it is concatenating, right? One array after the other array, right? But there are other possibilities also, like you can stack them together, like, or you can horizontally stack them or vertically stack them. Like that, there are different options available, right? So you'll see all those options. So let me take another two arrays. So two-dimensional arrays I'm taking this time. So some D equivalent to np dot array of some two-dimensional array I'm taking here, 1, 2 and 3, 4. So because if you take the two-dimensional array, there are two axes, x-axis, y-axis kind of, right? So there are two axes for two dimensions, as there are two dimensions. So np dot array of another array I'm taking, which is 5, 6, 7, 8. Okay. Oh, what's the time? 7:15. 5, 6, 7, 8. Okay, so now let me concatenate. So let me apply this concatenation operation on the multiple axes. You can apply it on the axis 0 or axis 1. So I'm just taking another array f equal to np dot concatenate of this d comma e. Okay, I think the default value for the axis is 0. Okay, so but you can explicitly also pass this. And let me take another axis which is concatenating it on the another dimension, axis 1. It is concatenating on axis 1 and another one is concatenating on axis 0. So let me show you the difference. I'm just printing both f and z. Now you see that. Let me take /n to make things clear to you. So yeah, so do you observe the difference? How f is concatenating, how z is concatenating. Axis 1 concatenation and axis 0 concatenation. So we have 1, 2, 3, 4 in the first array, 5, 6, 7, 8 in the another array. So if you see that axis 0, this is placing the second array below the first array. After 1, 2, 3, 4, we have 5, 6, 7, 8. Okay, so which is stacking it vertically, right? So if you see this, it is just concatenating this 5, 6, 7, 8 side by. After 1, 2, 3, 4, you are adding another array which is 5, 6, 7, 8 like that. So you see the concatenation. Do you feel the difference between them? Hello? Do you feel the difference
Yes,
between
sir.
them?
Yes,
Yeah.
sir.
Yeah.
Yes.
Similarly, there are some alternative functions for this. Stack function also there. Let me take a and b for this purpose. So here a and b are these two, right? So let me stack them together now. So let me take np dot stack of this a comma b. So I'm just stacking them together on axis 0. Right. Similarly, I'm just printing this directly instead of taking that into variable and doing all that again. Similarly, you can stack them on the axis 1 as well. Okay, so you see the difference. So when I give the axis equal to 0, one array is placed below the another array. Whereas when I stack them axis equivalent to 1, you see that how is it stacking, right? So 1, 2, 3 is the first column, then 4, 5, 6 as the another column, like that, right? So this is the difference. Similarly, there are other substitutes for this as well. Edge stacking, horizontal stacking, vertical stacking, depth wise also we can stack them. Okay, so let me show you that. So I'm just taking this, directly printing them. So print np dot h stack, horizontally stacking them. So stacking what? A and B together. So you know A is 1, 2, 3, B is 4, 5, 6. So now you see that this is how it is stacking. It is equivalent to this, directly concatenating them. So now I'm just stacking them vertically. Now you see that one below the other one, which is vertically stacking them. The other one is depth-wise stacking, which is stacking them depth-wise, right? It means 1, 2, 3, 4, 5, 6, like, okay. So sorry, 1, 4, 2, 5, 3, 6, like that, right? So it is the depth-wise stacking. So horizontal stacking, vertical stacking, and depth-wise stacking. So this is how you can stack them together. At lots of places we use these functions when you are doing this implementation of various algorithms from the scratch.
Excuse me, sir.
Mhm.
The difference between the axis equal to 0, it means
There
it
and
is
there,
stacking only.
please see that there are some, these are alternative functions. Okay,
Okay.
so some of them are, we can use them substitutions of the other functions. So there are various alternatives I've demonstrated. Some of them are same. Some of them are different. Some of them are same. So don't try to find the difference all the time. Some of the other substitutions.
Okay,
You
sir.
can, yeah. So let me take one array, np.array, to demonstrate one more concept. I'm just taking 6 elements here, 3, 4, 5, 6. Okay. So now I just want to split this array into multiple arrays of the same size. Okay. So let's say that I just want to split it into 3 arrays. So if I split it into 3 arrays of equal size, what are the arrays that I will be creating with these 6 elements? I can create 1, 2 as one array, 3, 4 as another array, and 5, 6 another array. Am I right?
Yes, sir.
Okay, so for this purpose, we use the np.arraySplit, array underscore split. Okay, so I'm calling np.arraySplit, and array I want to split is A, and how many splits I want to make? I want to make 3 splits. Okay, so I'm just printing this. Okay, so whatever it is returning, I'm just printing that. So I mean, whatever it returns, it is automatically printed here. I need not print, right? So np.cc that it is creating 3 arrays. First array is 1, 2, second array is 3, 4, third array is 5, 6. So suppose if I give 6 here, then what do you think it will give? Or 2 here. Suppose if I give 2 here, what do you think it will print? It will return
1, 2, 3, 4, 5, 6.
3, 4, 5, 6.
1,
1,
2,
2,
3,
3 as
4, 5,
one
6.
1,
array,
2, 3, 4,
then
Okay.
5, 6.
4, 5, 6
4,
as
5,
another
6 as
array.
another array. Great. Thanks for that.
So what if we have 7 elements and we are splitting it into 3 arrays?
Yeah. So suppose here if I split it into 4, it's not divisible by 6, right? 4 by 6 by 4, it's 1.5, isn't it? So it's not that you get 1.5 elements in this. First few arrays will be the seal of the um, number of elements. What is the seal of 1.5? 2, right? So the first few arrays will be 2 elements in each. The last few arrays will be the floor of this division, which means what is the floor of 1.5?
1.
1. Last few arrays will be only one element in this. So
I
suppose
think we should check that once.
you see that a comma 4 I am giving here. So these first 2 arrays is of size 2 elements in each. The last 2 arrays will be the size 1 element in each. So 2 elements because when you divide 6 by 4, you get 1.5. So the seal of 1.5 is 2. So 2 elements in each. First few arrays. The last few arrays will be floor of that. So 1 element in each. Got it, madam? Is that doubt clear? Yeah.
Yes, sir.
Yeah. So now suppose I just want to search for the elements that satisfy certain criterion. Like for example, let's say that I just want to search for all the even elements, indexes where the even elements are present, right? So what are the indices where the even elements are present in this array? Okay. What are the indices where the even elements are present? 1, 3 and 5. These are the indices where the even elements are present. Am I right? So 2 is located at index 1, 4 is located at index 3, and 6 is located at index 5. Am I right, madam? Is that correct?
Yes, sir.
All right. So if you want to get this even indexes, I mean indices where certain criterion is matching, right? So you can get that by np.where. You can specify the condition inside the where. What is the condition? It should be an even number. So a percentile 2 equal to 0. So this is what we want. So let me just name it with some variable x and print x. Okay. So now you see that it is returning you 1, 3, 5. So if you want to access the elements also, you can access them. Now suppose if I pass a of x, okay, so it will return you, oh god, I think, let me try this. Yeah, 2, 4, 6. Okay, so you can access the elements by using this indexes as well. All right. Got it, right? You can specify or you can look for the elements that satisfy certain criteria. Okay, using this where function. Okay, and most of the times we also use this initialization, right? So I just want to initialize a matrix of all zeros or matrix of all ones, something like this. Create an array of all zeros or all ones. Initialization, right?
P dot zeros.
Yeah, np dot zeros and np dot ones we use for this purpose. Excuse me. So I'm calling that x equal to np dot zeros. So you have to specify the size of this 3, 3, let's say. So you can print that. So this is creating a 2-dimensional NumPy array with all zeros, right? 3 by 3 size, all errors, all zeros. Similarly, you can create all ones also, np dot ones of, specify the size here. Let me just print this as well. Oh, indentation. See that it is throwing all ones. I see that. Okay. So similarly, you can also, matrix operations are very easy. So because as I have mentioned to you already, this NumPy library is for all the numerical vectorized computations. Okay, so you can perform various matrix operations like addition, multiplication, inverse, transpose, eigenvalue computation, or multiplication. So all that can be done using this NumPy arrays. So let us see that as well. Let us take 2 arrays which are of compatible sizes for the matrix multiplication. So let us take some 2 by 3 and 3 by 2. right? So let me take np dot array of some 2 by 3, 2 by say 3, 1, 1 comma 2 comma 3, another 1, 4 comma 5 comma 6, let's say. Okay, so you can take another 2-dimensional array, which is of 3 by 2 size this time. So 1 comma 2, 3 comma 4, and 5 comma 6. Okay, so you can see the sizes also. So what is the size of A and what is the size of B? 2 by 3 and 3 by 2. Are these compatible for the matrix multiplication? They're compatible, right? 2 by 3 can be multiplied with 3 by 2, right? So what is the resultant matrix size?
2 comma 2. 2 by 2.
2 by 2, yes. So to do this, you can directly call A at the rate B. This will do the matrix multiplication. You can print C and C dot shape as well. You see that shape of it is 2 by 2, and this is the resulting matrix 22, 28, 49, 64. This is a simple thing that you can do. You can do the another way also. C1 I am calling it as np dot dot, right, of A comma B. This will also be the same as that.
Sorry, is this A cross B?
Yes, A cross B. C1 dot shape. Okay. If you want element wise product, that is also there, madam. I will demonstrate that. C1 dot shape, it is the same as that, right? Say 22, 28, 49, 64, which is also of the same size as 2 by 2. Okay, so you can see it is a B. B is this. So suppose if you want to take the transpose of it, you can take B dot T, capital T, then it gives you the transpose. So I'm just taking this B dot T, which is a B transpose. You can see that, right? So the B is of size 3 by 2, B transpose is of size 2 by 3, 135 and 246. So now this B transpose is of size 2 by 3 and A is also of size 2 by 3. So can I take the element wise product of these two? Are they compatible for that? Both are 2 by 3, right? So you can take the element wise product. Am I right? Hello? You can do that. Am I right? Yeah. So print A and print B dot transpose and then print element wise product, which can be computed by calling np dot multiply of this A comma B dot T, which B transpose. So you can see that element wise product. 1 is multiplied with 1, resultant you got 1. 2 is multiplied with 3, resultant you got 6. 3 is multiplied with 5, resultant you got 15, and so forth. 6 is multiplied with 6, resultant you got 36. Right? So have you understood this? Shall we move on? Hello? Shall we move on? Yeah, so you can also compute the inverse operation. Inverse, like for example, let us take, what is this A, right? Okay, inverse. Let us take another variable, not this, because inverse is not possible for this. So let me just take x equal to np dot array of some 1 comma 2, 7 comma 8. Okay, so something like that. Okay, so x inverse I'm taking. X inverse is np dot linear algebra LINALG linear algebra dot inverse of x. Okay, so you can print this x inverse. You see that this is x inverse. So what is the property x when you multiply with x inverse? What is the resultant that you get when A is multiplied with A inverse? Identity matrix you will get, right? So x at the rate x inverse, if I give, I should get the identity matrix, isn't it? You see that I've got that 1001. Okay, so this is the x inverse. Similarly, you can compute the eigenvalues and the eigenvectors of any matrix. So you can see that to compute the eigenvalues, there is
So
something
sorry
called
to
ES.
ask. Can we just see what is X inverse?
X inverse is this.
But how we are getting by applying this linear algebra?
No, it's not linear algebra. This is a library name. Inside this, there is another library. The NumPy library, there is another library. In that, this function is there. The separate submodule of this NumPy module. You're calling the inverse operation, madam. Inverse function here, which is inside this linear algebra submodule. Got it, madam? NumPy is a one. If you see this NumPy as a one module, inside the NumPy there is submodule linear algebra. In that there is this function is defined inverse. Package, subpackage. Do you have idea about that in the live?
Yeah, yes, sir.
So inside that it is there. That's why we are accessing like that. Because we have not imported this linear algebra, no. I mean, directly we have not imported. We just imported the whole thing NumPy. Okay, that's why we are accessing through this NumPy. NumPy.linearalgebra.a. Got it, madam? Shall we move on? Is that fine, ma'am? Any other query you can ask? Don't hesitate, please. Is that clear?
The term inverse I would like to get clear, sir, actually.
env is the function name, like the way you call dot, the way that you call multiply here, it's a built-in function that you're just calling it. env. This is a function, built-in function. We're just making use of that function to get the inverse. So the inverse definition is defined in this. So we're just calling that function, like the way you defined your own sum function, right, earlier. Like this is defined in this library. You're making use of that to get the inverse of this matrix.
Okay, sir.
So, yeah, we got this dot np dot dot.
Yes. Those are clear, sir.
So this is a function, right, which is there
Yes.
in the NumPy library. Similarly, INV also a function. You're just calling that, making use of that function to compute the inverse of a matrix. Got it, madam?
My point is how that one got converted to minus 1.3, of course, through the function only. But what is that?
You want the procedure?
Yes,
There is the inverse. Do you know how to compute the inverse of a matrix? I can show you
Sir,
that.
actually, it is not striking at this moment.
But there is a process, no? That process is implemented in that function.
Matrix into the inverse of the matrix.
So you see that this is the process. You see this one, this will make things clear.
That's what this is what I was asking, sir.
1 by AD minus BC, D minus
Yes.
B minus CA, right? So
Yes.
D is what? You got it, right? D is the element here in A. Okay. So this is implemented inside that function. Okay, madam?
Yes, sir. That AD minus BC is the determinant.
So like that is why you got this. Okay, ma'am?
Yes.
Yeah. So to compute the eigenvalues also similarly, we have this EIG of X. Okay. np dot linear algebra dot EIG. So this returns two things, not just one thing. This returns the eigenvalues as well as the eigenvectors. So I'm naming eigenvalues as W, eigenvectors as V. You can print both of them. This will return both eigenvalues and vectors. So these are the first thing, W is eigenvalues. The second thing is eigenvectors. These are the eigenvalues, minus 0.62, 9.6. And these are the eigenvectors corresponding to that. So like this, you can have these multiple things in the NumPy array. You can even have this compute the minimum value, maximum value access wise. Like for example, let me take B for this, B. So B, okay, so let me take this. Suppose if I want to get a row wise sum, a row wise minimum, row wise, column wise minimum, like that. So you can call b dot minimum. So if I call b dot minimum, minimum of axis equivalent to 0, let's say. See that? So giving you column wise minimum, right? In the first column, minimum is 1. In the second column, minimum is 2. Suppose if I give here axis equivalent to 1, then it will give you the row wise minimum. So in the first row, minimum is 1. In the second row, minimum is 3. In the third row, minimum is 5. So like this, you can compute the minimum, maximum, sum, whatever that you want to compute. Okay. So a few more important functions in the NumPy array that we frequently use. One of the thing is the line space. Okay, so let me call np dot line space, linspace. Okay, we don't use e here. line will not use lin only. Okay, so the input for this is the starting number and the ending number and how many divisions that you want to create. 9, let's say. So let me just print x here. You see that it is starting at 0 and ending at 20. It creating 9 numbers with equal line space. So 0, then 2.5, 2 plus 5, 2.5, 5 plus 2.5, 7.5, 7 plus 2.5, 10, 10 plus 2.5, 12.5, and so on till 20. So 9 numbers in between 0 to 20 with equal line space it will create. Suppose if I give 11 here, it will create 11 numbers with equal line space 0 to 20, right? 0 to 4, 6, so on till 20. See that there are 11 numbers with equal line space. So got it right? What is line space is?
Yes, sir.
Yeah. So another similar one, but it is a different thing slightly. Arrange, np dot arrange. So this is also starting number and ending number you have to specify. Here we have to specify the step size. It means it will start at 0, end at less than or equal to 20. Every time it takes a step of 6. Okay, so it means 0 plus 6, 6 plus 6, like that. So we see that 0, 0 plus 6, 6, 6 plus 6, 12, 12 plus 6, 18, 18 plus 6, 24, 24 is exceeding the range, that's why it is stopping at 18. Okay, so this is the arrange function.
So
Okay,
all these functions are returning lists, right?
yes. And then these are returning NumPy arrays.
Okay, okay, sir. Okay,
It's
sir.
NumPy arrays because it's a NumPy library only, right?
Okay.
So yeah, so that's all about this NumPy library. Now we look into the pandas library. We may not be able to complete it as we have got only 20 minutes, but let us start. Okay, as we have 20 minutes time, we can discuss some of the things and we can complete it in tomorrow's session. And we probably will be able to complete also. So NumPy pandas is basically used to analyze the data and clean the data. Okay, so I'll show you how to, and it is also used for the visualization also. Visualization part we'll see tomorrow, how to use the pandas library for the visualization purpose. We can quickly go through it tomorrow. Okay, then in today's we'll see the analysis part and the cleaning part. Okay, so for this we'll be using some files also. That files also already shared to you on the drive. Okay. So before we start this pandas framework, could you follow the session? Are you with me?
Yes, sir.
Yes,
Yeah,
sir.
yeah. So please let me know if you face any problem. Please let me know so that I will correct that. Okay. Okay, fine. So let us start this pandas library. So again, to install the pandas, you have to type pip space install space pandas in the Anaconda prompt. So open the Anaconda prompt, go there, type this pip space install space pandas. So you'll be able to install this pandas. Okay, so once you install this, you can import it and use it. Okay, so import pandas as PD. PD is the name that I'm giving, short name that I'm giving for this. So you can imagine this pandas, like, I mean, there are two things in this actually, data frames and data series. So if you see this data series as a one column of the table, data frame is the table of the rows and the columns. So you can access this table row wise or the column wise. Anyhow, you can access them. Okay, so I'll show you how to create the data frame. Suppose we want to create a data of the student, and let's say that there are two attributes describe the student, name and the branch. Okay, so you want to create the student table with the two features of the, or two characteristics or two attributes of the student. One attribute is the name, the other attribute is the branch. Okay, so column wise we'll be creating this. So let me first define the data, and then I'll show you how to create a data frame using this data. So here the data is created using the, I mean, defined like a dictionary with the key values as the column names, name, and the values are the list of the values present in that column. Okay, so name is one column name. The list of values present in here are different student names. Ramu, some, let us give some names. Ramu, Somu, something like this.
Raju, Sai.
Yeah, anything you can give. I'm in one flow. Ramu, Somu, Kamu, whatever that you want. Yeah, Chota. Yeah, so the other one, I'm giving the branch of a student. Okay, so branch I'm giving. So branch, you can give any branch, CSC or EEE, CC, whatever that you want. Okay, so some names you can give. So let us create a data frame out of this. So data frame is equivalent to pandas dot data frame of this data. Okay, so now I can print this data frame to show you how it looks like. So this is the data frame in which you have, it's like a table, right, with the index values 0, 1, 2. One of the column is name, another column is branch, right? Right, like this you can create a data frame. So suppose now if you want to access names of the students, okay, or branches of the students, whatever. So if you want to access the names, just the names, so you can access it by calling df.name. Name is the column head, right? So now you see that you have only got the names Ramu, Somu, Kamu. You can see that, right? So suppose if I want to access branch, then I can just access only, what should I write if I want to access branch information?
df.branch.
df.branch. There is another way of writing this. Let me try that way here. df.branch you can write, definitely you
Brackets
can write.
branch.
Yeah, df brackets branch. You can specify the branch here inside this. Okay. So through this way, you can access the multiple columns at a time. Suppose if I want to access name and branch also, you can access. I mean, here name and branch only 2 columns, but suppose there are 10 columns, you want to access 2 of them. You can specify the 2 names separated by the commas and give that. Okay. So this way you can access the multiple columns at a time also. So you see that only branches. Okay. So here we are accessing the column wise. Like for suppose I just want to access the details of a particular student, right? So I just want to access the details of a SOMU, right? So what is his index number? SOMU index number? 1, right? Okay. So let me just print this data frame again for our reference. So I just want to access the details of the student present at index number 1, right? So then you can access it like df dot location, specify the index number here. Now you see that you've got the details of this SOMO, right? Name is SOMO, branch is EEE. So suppose I just want to access the branch details of SOMO, then you can access df dot location of one dot branch. Okay, so this will access the branch detail of SOMO. You see that EEE, right? So like this, you can access this data row wise or the column wise. So you can even create your own indexes also. Here default indexes are 0, 1, 2, so on like that. Suppose you want to create the index numbers as the roll numbers of the student or some name you want to give your own customized index numbers, right? So that is also possible. So I'll show you how to do that. So let us take this same thing again here.
So before that, I have one question. Is it possible to convert the data frame into NP array?
Uh, Data frame into NP array. Okay, I have never tried it, but looks like the format doesn't support it. Okay, so you can try it. Let us just try what is wrong. So this is I don't think it will support. Let us see np dot array of this data frame, right? I've never tried it. Yes. Oh God.
We can convert it, sir.
Yeah, array, numpy array.
Dot two underscore numpy.
Uh-huh.
Using this function, we can convert it.
Sorry. What is that you said?
We can use data frame dot two underscore numpy.
Oh, data frame dot numpy. Okay.
Data frame dot two underscore numpy, and where we have to specify data type also.
Okay. All right. Anyhow, this conversion is also done. Okay.
Sir, it looks like as if every row is considered as the list.
Yeah. One dimensional array. Yes, one row is one dimensional array. All right. Yeah. All right, ma'am. Is that okay? Shall we move on?
Sir. Thank you.
So we can have our own indices as well, index values as well. Like for example, data comma index. Index, you can specify the index names. Like for example, you can give your own index values X, Y, Z, some anything like that. Okay. So your own index values also you can give. Okay. You see that now instead of 0, 1, 2, you've got the index values as X, Y, Z. So now suppose if I want to access SOMO details, how can I access this? Df dot location of specify the index value, which is y. You got right. SOMO entry. All right. So like this, you can access. Okay. So similarly, you can have the data series also by defining pandas dot series. You can have the one-dimensional this data frame, which is like one column in the table, right? So then I'll show you how to read this data from the files, local files or from the URLs, wherever it is. So I can show you the file also. If you want. Files are not here. I think files are not here. Let us get that. Yeah, this is how the data is looking like. We have 4 columns here: ID, name, branch, and age. So each student is described with respect to the 4 attributes: ID, name, branch, and age. Okay, so let us just import this data. Okay, so to do this, this is like sample2.xls, right, which is in the same folder. So if you want to access it, access or load a file which is there at another folder, you have to give the complete path. And if you're doing it in Google Colab, you have to first upload it. There are some 2 lines of code that you have to write to upload a file to the Google Colab. Then you have to write the statement. Okay. Here I'm taking it as a data frame 1 or data frame 2, let us say. Okay, so pandas dot read excel. Okay, give the file name here within quotes. So sample2 dot xls is the file name. Okay, so I can just print this data frame for you. df2. You see that you got this 4 heads, right? Each student is described with 4 attributes: ID, name, branch, and the age. So this is a simple file in which you have got 6 records. What if you have got thousands of records and you want to see how the data looks like? It's not possible to print all these thousands of records, right? So in that case, you can access the first few records by calling df.head. Okay, so it will return, I think, first 5 records of this, but you can have option to specify how many records that you want to access. So if you specify head of 3, first 3 records will be accessed. Okay, so you have an option, you see that the first 3 records, right? Similarly, you can access the last few records also by calling this tail function. Okay, so tail function, last few records it is accessing. Can even get the information about this attributes as well, that how many values are there, how many non-null values are there. That information you can get by accessing info. So you can see that here in info, you got 4 columns are there, non-null values are this many, the data type, everything is listed out here. Information about each and every attribute is mentioned here, right? So this is how you can access. Like suppose now if I want to access, and this is the data frame, I'm just printing it for you. Oh, data frame 2. So now suppose I want to access ID, or I just want to access the ID and branch of a student. How do you do that? ID and branch, 2 things I want to access. df2 of ID and branch. How do you do that?
We will give ID in the curly braces, in the braces.
Comma, branch.
Branch. Okay. So now you see that. Oh, I think this should be passed like a list.
One more square bracket.
Still, I'm surprised. Did I give any? Okay, branch. Yeah, ID and branch. Suppose if I just want to access the first 3 people ID and branch, then how can I give this? And open another bracket, specify the starting index and the ending index plus 1, right? So you see that the first 3, 0, 1. Suppose I just want to access the alternative student information, ID and branch of the alternative students. So starting at 0 till the end, I will proceed. Okay, so you can not mention 0 as well. Okay, colon is 2, colon, step size is 2. Then you see that you're accessing the alternative elements, alternative student details, which is the step size 2 here. So like this you can access. Fine. Anything else? The next one is, suppose I just want to search for the students or the records, students with age less than or equal to 20. Okay, So I just want to search for the students with the age less than or equal to 20. How do you do that? How do you do that? What is the condition here? How do you mention the condition? Age should be less than or equal to 20, right? Okay. So suppose if I give df dot age less than or equal to 20, less than or equal to 20. Okay, so what it will return?
It will be DF2, sir.
df2, okay. So what is returning? It is returning those index numbers with the corresponding condition as a true or false, right? Right. So now suppose if I give this in the location, right? So df dot location. It means it will access those with the indices satisfying this condition, right? So df dot location of df dot age less than or equal to 20. So just print this. So this will return the indices with age less than or equal to 20. What went wrong? df dot location. Okay, this is not this bracket. Still, okay. Are we missing any
DF2.
bracket?
DF2.
df2, okay. Yeah, you see that you've got less than or equal to 20, right? Correct only, right? 20, 18, 90. All of them are less than or equal to 20. Okay. So fine. Is it okay if I continue it for 5 more minutes, because we can close this pandas and start?
Yes, sir.
Yes, sir.
Yeah.
Sir,
See,
obviously, it's possible to store it in another data frame.
yes,
This
this will not make
filtered
any
records.
changes. Yes, yes. It will not make any changes to the original data frame. It will return this. If you want to store it in another data frame, you can store it like df3 equivalent to df2 dot this.
Okay.
Yeah. Okay. See, you can even sort the values also. Like sort them according to a particular row. Like for example, I just want to sort these records according to the ages, right? So you can call df2 dot sort underscore values. Okay, and then give this age. Then you see that it is sorting them based on this age 18, 19, 20, 21, so on 22. So this is just returning it, right? So similarly, if you want to make them sorted in the descending order of the ages, then you set the ascending equal to false. By default, the ascending equal to true. If you want to make it in the descending order, set this ascending to false. This will sort them in the descending order. Okay, as you see here. Similarly, if you want to access the .csv file, there is a function called read underscore csv. So you can use that read underscore csv, mention the .csv file name inside that, similar the way that we have written here. So it will load that .csv file. Okay, so there is another thing that I wanted to demonstrate. Like, so if you take the data, there may be some duplicates sometimes, right? So how to drop the duplicates, how to deal with the duplicate rows, how to handle them, or there may be some not known values, NaN values. So how to deal with this NaN values. So this part we will see, and we will conclude this session. So let me take another data for this purpose. So let me take data frame 3. Okay, so pd.read Excel. Another file I am loading here, students.xls. Okay, so I can just show this df3 to you. So this is the also student information. We have 7 columns: ID, name, branch, age, subject 1 mark, subject 2 marks, subject 3 marks. You see that in this data there are some duplicate values. Like for example, the last row is duplicate of the 7th row. Okay, so it's a duplicate information, and there is a value here which is NaN value, right? So it's not known. So how to deal with these kind of things? How to handle the duplicate records, or how to handle this NaN values? So let us see that. So you can drop the duplicates by calling drop underscore duplicate. Okay. So if you take df3 dot drop underscore duplicates, okay, so this will return a data frame after dropping the duplicates, but it will not make any changes to the original data frame. Okay, so it will not make any changes to the original data frame. Data frame 3, df3 will be the same, but it will return the data frame after removing the duplicates. So if you want to replace it with the original, you can say that df3 equal to df3 dot drop duplicates. That is one possibility. The other possibility is you can set the in place equivalent to true. So you see that this is the data frame after dropping the duplicates. You can see that the last row is removed, right? Suppose if you set the in place equivalent to true, it will not return anything, it will return none, but it will make changes to the original data frame, df3 itself. So it is making the changes in place, right? In place, it means it is making changes to that data frame itself, but it will not return anything. So now it is returning none, but now if you print data frame 3, df3, you see that it is the data after removing the duplicates. So the duplicate row has been removed. Okay, so this is how we handle this duplicate rows. There is NaN value here, you see here. So how to deal with NaN values? Okay, you can either fill them with some default value, or you can fill them with some mean value of that column, or you can drop them as well. Okay, so to drop these NaN values, there is a function called drop Na. So this is also not in place by default. Okay, if you want it to be in place, you have to set the in place equivalent to true. So I'm just calling this print df3 dot drop Na. Drop Na function, this will drop the NaN values. So, and it will return that. It will not make any changes to this df3, but it will return that data after handling that NaN value. Now you see that you don't have any NaN values here, right? So it will just drop off there. And now suppose I just want to make it in place, then you have to set this drop Na inside that in place equivalent to true. Okay, so I'm not doing this, you can do it later, because I just want to demonstrate few more things on the same thing. So I'm just doing in place equal to true, then it will make changes to that. Okay, so there is another thing that you can do, that you can set this NaN values to some default value. Like for example, where is this in the subject 2, right? In the subject 2 we have NaN value, right? Subject 2, right? So you can access that. So df3 dot subject to s2 dot fill Na. Instead of calling drop Na, you call this time fill Na. Fill it with some default value, let's say 100, okay, or some average some value 60. Okay, fill it, or some give some 75, let us say some that now you print this. This will also not make any changes to the original. If you want to make it, you set df3 dot s2 equivalent to df3 dot s2 dot fill Na, right? Yeah, you see that now that is replaced with 75, as you see here, the fourth row, it is replaced with 75, right? So even you can fill it with some average value also, like if you want to fill it with the average value of that that column, you can do that. Okay, so df3 dot s2 dot fill Na. So with what you want to fill? Average of that column, right? df3 dot s2 dot mean, right? Mean value. So now we see that it is filled with the average value 75.66667. That is the average value of that column. So this, as I said, this will not make any changes to the original one, right? I can show you that. The df3 I am printing, you see that it is not making any changes. NaN is still there. If you want to make it changes to the original one, you can replace it with that column. So now I'm just making this change df3 dot s2 equivalent to this updated column. Now you print this df3. Now you see that.
Sir, in place is also used to make changes to original data frame.
Original data frame, yes. Yes.
Sir, can't we write mean के बाजू ही comma in place equal to true?
In place equivalent to true, fill in a. Okay, I think it is there. Let us check this. Valid, invalid keyword. Give me a second. Please give me a second.
So there is a misplaced brackets parenthesis. It should be just after name.
No, fill in, yes, yes.
At the end, you need one more bracket.
No, I think it is correct. Okay.
At the,
Okay.
after true.
Replace the, yes. Done. In place equal to true also you can do. That df3.s2 for all those things. In fact, the previous in places also you
We are
can.
getting 3, 3, 2, 2 like that.
Sorry.
Down, you go, just go down, sir. 3, 0.
No, this is like that column is going the next row because my font I set to be big, because of that it is happening.
Okay.
It is that is actually that row is going to the next row because of the bigger font that I set for the presentation purpose. It will not happen for you. All right, so that's all. That's how we can clean the data and analyze the data. Tomorrow's session we'll see how to use the pandas framework for the visualization purpose, as well as we'll also see how to use matplotlib for the visualization purpose. That we will quickly complete, and then we will move to this probability concepts. Okay, so that's all for today. So thank you very much and happy learning. If you have any queries, you can ask.
Thank you, sir.
Otherwise, we will.
Sir, can you send the recording, today's recording session?
Yeah, sure, ma'am. I'm updating that in the